Database design and the entity relationship model. The design of a database is both art and science. It requires good judgment in establishing which information is needed, and organizing it in a way that creates no problems when manipulating and accessing the database, coupled with tools that aid in the optimization of the design. Ideally, a database represents the real world. Therefore, the aim of the design process is to obtain a model for the database that is a representation of the world in simplified terms, an abstraction of the real world. Directly defining the relational model for a database is not an easy task, and may lead to problematic designs. In practice, designers define the conceptual design of the database using concepts more close to the real world, and then translate this conceptual design to a relational one. A very popular conceptual design model is the entity relationship model. The entity relationship model is a model for the conceptual design of databases. It was developed for database design by Peter Chen, in 1976. However, variants of the idea existed previously. It is still very popular and it is used as a first step towards the design of a database schema. Essentially, the designer builds the entity relationship model of the database, using analogies to the real world, and then one translates the conceptual design into a relational schema suitable for the database management system. The basic concepts of the entity relationship model are the entities, the relationships, and the attributes. Entities correspond to real-world objects, either tangible or not. Examples are employees, customers, suppliers, products, parts, courses, flights, sales, etc. Relationships correspond to links between the entities. Examples are which courses a student enrolls in, which products a sale includes, which employees work in a department, which flights depart from an airport, etc. The attributes are information that characterizes an entity or a relationship. They correspond to the properties of the entities or the relationships. Example attributes are the name of an employee, the credit points of a course, the date of a flight departure from an airport, etc. The notion of attributes is similar to the one in the relational model. When discussing entities, we should differentiate between the entity types, that are groups of objects having similar properties, and identified as having independent existence. A specific entity, also called entity occurrence, or entity instance, is a uniquely identifiable object of an entity type. Entity types are represented by rectangles containing the name of the entity type in the entity relationship graphical diagrams. The very simple diagram shown has two entity types, one for the employees, and another for the departments. Relationship types are groups of meaningful associations between members of the entity types. A specific relationship, also called relationship occurrence, or relationship instance, is a uniquely identifiable association, which includes one entity occurrence from each participating entity type. Relationship types are represented by rhombuses containing the name of the relationship type, with lines connecting it to the participating entity types. The simple diagram shows a relationship type expressing the works in relationship between employees and departments. Relationships types may be differentiated by the degree of the relationship, that is the number of the participating entity types. The most usual relationships are the binary ones between two entity types. However, there are also ternary, quaternary and higher degree relationships. The degree of a relationship is evident by the number of lines that connect the relationship type to the entity types. Relationship types may also be differentiated by the number of times an entity occurrence may participate in associations of the relationship type. We consider the cases where an entity occurrence may participate in only one association, and in multiple associations. For binary relationships, that leads to relationship types that are one-to-one, one-to-many, and many-to-many. An example of an one-to-one relationship type is between managers and departments, where each manager manages only on department, and each department is managed by only one manager. An example of an one-to-many relationship type is between departments and employees, where one department may have many employees, but each employee works in only one department. An example of a many-to-many relationship type is between parts and products, where a part may be used in many products, and a product may use many parts. The multiplicities of the relationship types is shown by symbols in the lines that connect the relationship type to the entity types. In the simple diagram shown, the works in is a many-to-one relationship type. The attributes, similarly to the relational model, are properties of the entity types or the relationship types. The attribute domain is the set of allowable values for one or more attributes. Attributes are represented by ovals, and are connected by lines to their entity type or relationship type. In the diagram shown, the entity types have a few attributes, but the relationship type has none. A simple attribute is an attribute composed of a single component. A composite attribute is an attribute composed of multiple components, each with an independent existence. For example, the name attribute in the previous entity relationship diagram is composed of two components for the first name and the last name. A single-valued attribute is an attribute that holds a single value for each occurrence of an entity type. A multi-valued attribute is an attribute that holds multiple values for each occurrence of an entity type. An example of a multi-valued attribute is the attribute phone for a contact in an address book, which may hold multiple phone numbers. The notion of keys in the entity relationship model is similar to the one in the relational model. A candidate key is a minimal set of attributes that uniquely identifies each occurrence of an entity type. The primary key is the candidate key selected to uniquely identify each occurrence of an entity type. A composite key is a candidate key that consists of two or more attributes. Primary keys are underlined in the entity relationship diagrams. Designing the conceptual model of a database is an iterative process, and it mainly consists of the following steps. Step 1. Ask the right questions. What are the data needed for the application? How are these data linked together? What are the queries to be asked to the database? How the data needed correspond to entities and relationships of the real world. Step 2. Identify the entity types. What are the real-world entities types that correspond to the data identified? Step 3. Identify the relationship types. What are the meaningful relationship types between the entity types identified, that are needed to link data together, and are used to retrieve information from the database? Step 4. Identify attributes. What are the properties of each entity type and relationship type that are needed? Step 5. Determine the attribute domains. What is the range of acceptable values for each attribute? Step 6. Define the entity relationship model and draw the entity relationship diagram. Step 7. Check the model for problems. This involves looking into various issues such as: are the entity types and the relationship types independent of each other? Does one entity type actually describe two or more different objects? Are some attributes properties of an entity type or do they represent a different entity type? For example, is the building attributed a property of the department, or do we have to add an entity type for the buildings and a relationship type representing which department resides in which building? Are two different entity types actually corresponding to the same object? Do relationship types express the correct association between the correct entity types? Does the same information appear in several places? For example, the building may appear both as an attribute of the employee and as an attribute of the department. Step 8. Correct the model. That means to find ways to fix the problems, and revise the model, by, for example, merging or splitting entity or relationship types, shifting attributes to the appropriate entity or relationship types, etc. Step 9. Review the model with others involved, such as developers of applications, database administrators, etc. Repeat the process of modifying and reviewing the database model, until the result is satisfactory. Please note that formal methods exist to optimize the database design, such as the normalization of the model into some normal form. However, these are beyond the scope of this learning module. Usually, a model that feels natural is more or less a good model. That means that if the entity types and relationship types are in accordance to the common understanding of the real-world objects and associations involved, then most probably the model does not need major corrections.